Welcome to SPT online classes, and today you are going to study how to find out significant figures and how to do rounding. So instead of telling all the rules of significant figures, let's go through each example and learn rules from there, because most of you who are watching this video might be knowing the rules of significant figures from your textbook, which is there in the NCERT, right? So there is no meaning in explaining the theory part again, so let's go through each example and let's calculate the number of significant figures in each case. The first number is 832. Number of significant figures will be, yeah, you guessed it correct, it's 3. So number of significant figures is 3. Okay, that's the reason is because we have a set of numbers here which is all non-zero figures, so all are significant. Number 830, 830, we have one trailing zero, means one zero at the end, which is not significant until and unless it is mentioned in the question that that zero is significant. So in this case nothing is mentioned, it's just a number, so that zero is not significant because it is in the trailing end. So only two significant figures, which is 8 and 3. But when a zero lies in between two non-zero figures like 803, then that zero has to be considered as significant. So both all three numbers 803 are significant. When it comes to the next number 8030, we have one trailing zero and we have one zero in between two non-zero figures. So that means we have 803 as significant. So the answer will be 3. Understood? Now in the next number a decimal is coming. So now the rule is slightly shifting. When a zero is coming at the end of a decimal number, that zero should be treated as significant. So number of significant figures in this case is 3. Okay, so according to the rule just set now, in the number 0.830, this zero will be significant, but the numbers towards the left of a decimal number are not significant. So the starting zero is not significant, this zero is not significant, which means we have only 3 significant numbers in this case, which is answer is again 3. Here once again you can see that 2 zeros are preceding the number 8 and 3, so though these zeros are not significant. Okay, and we have 2 numbers over here, so significant number is 2. Here also we have 1 0 which is in the end, so it is significant. So total significant numbers 3. Here in this number 2.7 into 10 raised to minus 3, we don't have to consider anything about exponents, so just 2 significant number, which is 2 and 7. In 3.24 meter, when units are coming, it is insignificant, we don't have to bother about units, so answer will be 3. Number of sides of a cube, it's absolutely a constant number, it's not going to change at any cost. So cube will be having 6 sides, so that doesn't mean the significant number is 1. The answer will be infinity because it is a constant. So constants will be having infinity as the significant number. A pure number 362 once again will be having the significant number as infinity and not 3, because it's already mentioned the number is pure. In a pure number 300, the significant number is not 1, it's once again infinity because it's mentioned it is pure. Understood? In the number 800 into 10 raised to minus 3, we have only one significant figure, which is 8. The exponent we don't have to bother, trailing zeros we don't have to consider. In the number 800 point, we have 3 significant figures because a decimal number is coming. So anything in between a non-zero number and decimal Yes, definitely significant. So 3 significant figures. In an exact number 999, the significant figure is infinity. It's not 3, because pure number, exact number, constants are all having infinite significant figures. Something, a relation which is given like 10 decimeter equal to 1 centimeter, it's also exact, so it's also having infinity as a significant count. And a number is given as 10 decimeter. I already mentioned that unit is not to be considered, so the significant figure is 1. Even in the case of 1000 meters, significant figure is 1. But once it is mentioned as $9, 8 rupees, 7 pounds, something like that, then it will be having infinite significant figure. Infinite, because it's a constant. $9 means $9 itself. Okay. The number 2000, in the number 2000 we know definitely it's only one significant figure, but in case if they are telling that up to 3 numbers are significant, then they have already given the condition that up to 3 numbers are significant, so answer will be 3. Hope you understood how to do the significant figures part. So a lot of examples we have done, and I don't think any question can come beyond this set of numbers. So just learn these examples for your exams, which will make it easy. Okay, now let's get into rounding. So next is rounding. In rounding, there are 2 ways the question can be asked. The first method is round off to a specific number of decimal places, or round off to a specific number of significant figures. Here, let's first look at to round off into 2 decimal places for these set of numbers given. The given number is 42.7332, which we have to round off to 2 decimal places, means the answer should have only 2 decimal points, 2 decimal places after the decimal point. So let's round off this number, 42.7332. The answer will become 42.73 itself. The reason is because the rounding we have done over here to this number 3. The very next number after it is less than 5. So our rounding, after rounding, the number will be retained as 3 itself, 42.73 itself. Okay, let's try the next number and we can avoid reduce the confusion. So let's round off 42.7662. So the rounding should happen over here. So the very next number to it is greater than 5. So the answer will be 42.77. Now hope you understood the method of rounding. Here, the third number 42.7552, rounding should happen over here. The very next number is 5, followed by few numbers other, followed by few non-zero numbers other. So once again, the answer will be 42.76. This time we have to add 1, because if 5 is coming, then there are actually 2 rules. The first rule is that we have to check whether any non-zero numbers are following that particular number 5. If so, you have to add 1. That's what we did now. A non-zero number is following the 5, so you have to add 1. In the case of 42.7550, okay, the rounding should occur here. The next number is 5, followed by zeros only. So then comes the new rule. The new rule is the number which we have to drop, you have to check whether it is even or odd. If it is an odd number, which means our 5 is an odd number, you have to add 1, that will become 42.76. Understood? If it is an even number, you have to retain. That's what happens in the next case. In this case, you can see here we have to do the rounding. Next number is 5, followed by zeros. So the number you have to check, this number which you are dropping, you have to check whether it is even or odd. If it is even, retain the number 42.76 as such. Understood? This is how to round off into a particular decimal place. Okay, so if I ask, say, a number 42.7892, and if I need to round off into, say, 3 decimal places, how we will do? You have to do the rounding over here. Correct? The next number is less than 5. So the answer will be 42.789. Understood? If you want to round off to, say, the same number 42.7892, 42.789. Instead of 2, let me replace the number 2 with a number which is greater than 5, say 8. Now if I want to round off into 3 decimal places, how will I do? The method is, the number next to 9 is greater than 5, so you have to add 1 over here. Okay, once you add 1, what will you get? 9 plus 1, 10. This 1 will go up, so 9, 7, 4, 2. So the rounded figure will be 42.790. This is how you have to do. Understood? Okay. So hope you understood the concept of rounding off to a particular number of decimal places. Okay, next we can round off to a set of significant figures. Okay, so the given set of numbers, we have to round off the following numbers to a particular significant figure. That's what we have to do. So the first number is 26567. We have to round off to one significant figure. So if you see, the first significant figure is 2. So you have to round off into one significant figure, means you have to do the rounding over here. So let's use the rules. The next number is greater than 5. So the number, you have to add 1 to it. So where you have to add 1, you have to add 1 to number 2. That makes it 3, followed by set of zeros, 1, 2, 3, 4. Understood? So that's how you will round off to particular set of significant figures, and especially in the case of whole numbers, when you round off, you have to be careful. Let's see the next number, 136.4. You have to round off to one significant figure, means in the final answer there should be only one significant figure, means this is my first significant figure where I should do the rounding. The next number is less than 5, so answer will be 100. Got it? Because 136.4 is closer to 100, and you cannot round off that number to something else. You can round off only up to 100. Now if you take the number 0.56, you have to round off to one significant figure. My first significant figure is here. I have to do the rounding over here. Okay, the very next number is greater than 5, so the answer will be 0.6. In the answer there is only one significant figure. Understood? The next number, 78.3665, we have to round off to two significant figure, which means rounding should occur over here. The next number is less than 5, so the answer is 78 itself. If I want to round off the same number to three significant figures, I have to round off here. The next number is greater than 5, so 78.4. Understood? So once you keep on doing few examples, you will understand how to do it. The number is 0.359. I have to round off into one significant figure. The next number is 5, followed by some numbers. So definitely you can add 1. The answer will be 0.4. Here we have to round off to two significant figures. I have to do the rounding over here. The next number is greater than 5, so 0.36. Here I have to round off to two significant figures. 3595 number is whole number. The next number is greater than 5, so the answer will be 3600. Understood? In the number 3951, which you have to be careful. Here I have to round off to two significant figures, means I should do the rounding over here. The next number is 5, followed by some numbers others, so definitely I have to add 1. Once you add 1, you are going to get as 4000. But then there is a confusion, because the answer is only having one significant figure, and the question is to round off to two significant figures. So the answer actually should contain two significant figures, but the answer is 4000 itself, in which 4 and the first 0 followed by 4 both are significant. Understood? So this is a special number which you have to be careful, 3951, where you are rounding the number 9, because the number followed by 9 is 5, and 5 is again following by a non-zero number, so you have to add 1. You added it, you got 4000. In the number 4000 there is only one significant figure, but it should contain two significant figures. But according to the rule, it's like the first two numbers will be significant in that case. Understood? Simply a number is giving to you, say 4000. How many significant figures are there? Answer is only 1. But if a question is asked to round off to two significant figures, means it's clearly mentioning that the first two numbers are significant. In that way, the number 4000 here will be having two significant figures. So answer is 4000 itself. You don't have to do anything. The method you have done is correct only. Okay. In the number 0.0039, you have to round off to one significant figure. The first significant figure is 3. You have to do the rounding process over here. The next number is greater than 5, so 0.004. The number 0.0099, you have to round off to one significant figure. The first significant figure is 9. You have to do the rounding. The next number is greater than 5. So how will you round off? You have to add 1. You have to add 1. That will bring the number to 0.01. Understood? Because you are adding 1 to it. You are adding 1 to this 9. So you are getting 0.01 only. The next number 0.00909, you have to round off to one significant figure, means you have to do the rounding process over here. Next number is 0. So the number will retain as 0.009 only. Understood? So that's how you should round off to a particular significant figure. Understood? So you can copy these numbers and you can study it for your exam. This is how you should do. The only thing you have to be careful is this number. Okay, if a number simply 6000, 7000, 8000 is given, only one significant figure is there, but the question is asked to round off to two significant figures, three significant figures. In that somehow a zero is coming, then you have to treat that 0 as significant, which means here the number 3951 has to be rounded off to two significant figures. We rounded it by adding 1. We got 4000. In that 4000, the first two are significant. Okay, you don't have to change rules for that. The rules should be followed as such. Okay. Something I wish to add on to this particular video is the concept of order of magnitude. In the concept of order of magnitude, one thing you have to note is the order of magnitude depends. Okay, it depends on unit. So order of magnitude is going to depend upon unit. Let's see how to calculate the order of magnitude. This is also easy. So the process is like this. Suppose a number is given 4, 3, 2, 8. What you have to do is that you have to check the left extreme non-zero number. The left extreme non-zero number is 4. If that number is less than 5, then you have to immediately write 4 point. That particular number point. Then write the following numbers, which is 3, 2, 8. Then what should I multiply with this 4.328 to get my number which is given in the question? I should multiply with 10 to the power 3. Then the order of magnitude is 3. Understood? This is only what you have to do. So say number 432.8. Left extreme non-zero number is 4. So once again, write the number 4 point, then write the following numbers as such. What should I multiply with this number to get the number which is given in the question? 2. So the order of magnitude is 2. Let's keep on writing. What about 4.328? 4.328. I don't have to do anything over here because the order of magnitude for this case is 10 to the power 0. So the order of magnitude is 0 itself. But what if the number is coming like say 0.4328? Once again, the left extreme non-zero number is 4. So you have to write 4 point itself. Write the remaining terms. Now what should I multiply this time? I should multiply with minus 1. Then only you get the order of magnitude as minus 1. Then only you will get the number which is given in the question. Understood? If a number say 7248 is coming, the left extreme non-zero number 7, which is greater than 5, so what you have to do? This time you have to put the decimal point first, then write the remaining terms 7248, multiply with 10 to the power what you should write to get the same number, 4. So the order of magnitude is 4. Number is 7.248. What about 7.248 is coming? Then once again 0.7248 into 10 to the power. In order to get that, I should multiply with 10 to the power 1. The order of magnitude is 1. Understood? Now if the number is 0.7248 is coming, here I don't have to do anything because once I put the decimal, then write the following numbers. I am getting the same number as that of the given question, so just put 0. Answer will be, order of magnitude will be 0. In the number 5001, what about a number say 5001? What will happen? The left extreme non-zero number is 5. So we have studied cases less than 5, more than 5. What about 5? Then look, is there any non-zero number following that particular 5? Yes, we have a non-zero number following that 5. So you have to treat this case as that of the previous case, which is first you put the decimal, write the remaining terms, then multiply it by 10 to the power 4. You have to do, order of magnitude is 4. So in the case of 5100 also the same thing you have to do. The left extreme non-zero number is 5. Yes, some non-zero number is following that 5. So you have to treat it as 0.5100 into 10 to the power 4. Order of magnitude is 4. In the number 5000, the left extreme number is 5 followed by completely 0. So this time you have to write it as 5 point, then write the remaining zeros, 000 into 10 to the power 3. The order of magnitude is 3. What if the number is simply 5? If the number is simply 5, then what you have to do, it is simply 5 into 10 to the power 0. The order of magnitude is 0. Now as I said, the order of magnitude rules depends upon units. So let's do something like that. Regarding that, 3.24 meter. Okay, now you can do this since the left extreme number is less than 5. You have to treat it as 3 point, then remaining terms into 10 to the power 0 in order to get the same number given in the question. Order of magnitude we know it is 0. In the 3.24 meter itself is 324 centimeter. So in this case, once again what you have to do is 3.24 into 10 to the power 2 you have to do in order to get that 324. The order of magnitude is 2. So even though 3.24 meter is equal to 324 centimeter, the order of magnitude will be different. That's why I told order of magnitude depends upon the unit. Not like significant figures. Okay, now say the number 4358 into 10 to the power minus 10 meter. What will happen here? So as I said, the left extreme number is less than 5, so write 4 point, then 358. What should I multiply here? I should multiply into 10 to the power minus 7, so that to get the order of magnitude as minus 7. Got it? The reason is because 4358 is equal to 4.358 into 10 to the power 3. Then remaining number 10 to the power minus 10 is the which gives you this one, 4.358 into 10 to the power minus 7. So that's how we do the calculations for order of magnitude, significant figures, and rounding. Hope you understood today's class. You just keep on doing problems. Then we have another set which is the rules for addition, subtraction, multiplication, and division. That's for another video. So I hope you understood today's class, and thank you.